Hi all, I'm Anthony, and this is going to be my description of my Minesweeper project with using UML format. So I generated my UML using Doxygen, which is a automated tool that generates documentation for you, which includes UML diagrams. Um, so it's a pretty easy way to get some quick and easy documentation started for your project. If I go in here and I go open my HTML, I can actually show you guys what the UML diagram is going to look like. So this is going to be a file reference. We're not going to worry about this too much because it's not actually relevant to what I'm talking about today. But we can see we have a main page, we have some classes with a list of all the classes, and we have the files. So I'm going to go through the file list first because I think this makes a bit more sense if I talk about how I structured my Minesweeper beforehand. So my Minesweeper is extremely object-oriented. So there's a lot of classes involved because I did the MVC model, that is your model, view, and controller, MVC. Essentially, what I did was I split each part of the project into three different classes. So, for example, let's take our mine counter. Our mine counter has really three parts of it, right? Actually, Actually, let's talk about the board instead. The board has three parts of it. It's got a business logic part, which is maybe your data structure for how your mines are laid out, like maybe you do a 2D list or something. You have your view part, which is your visual representation of your board. So that's what the user sees. That's your tile revealed, tile hidden, whether or not the flags are shown, whether or not mines are shown, stuff like that. And then you have your controller that hooks that back-end business logic, that model, up to your front-end sort of visual representation, your view. Your model and view get combined, and that's controlled by, well, the controller. And the controller also will handle like clicks and keyboard input, which is stuff that matters if your model needs to react to a mouse input or your view needs to react to a mouse input. It's all handled by the controller. So essentially, I have like three times as many classes as I have like things on the Minesweeper board, I guess, is one way to put it. So if I actually scroll through here, if I look at like my board, like I was just talking about, I have a controller, I have a model, and I have a view. Chords is a little helper class that I made. So that one only has itself. But if we go through here, we see we have everything organized nice and tidy into folders. So we have a board, graphical user interface, GUI. Then we have some buttons, leaderboard, mine counter, stopwatch, and then the actual like GUI stuff. The board itself has some tiles. So now onto the actual UML. So go ahead and head over onto not main, go to game here. No, one of these guys. Here you go. Class hierarchy is actually what I want here. So here's our inheritance relationships. I didn't use a whole lot of inheritance for the project. So pretty much all I had was a button controller that was an abstract based class for a bunch of other button controllers, and then a button view that had some state involved with it. So a face button view also inherited from that. So we'll go ahead and move on to the class list, and we'll go look at the game class because this is sort of like the big class that holds every other class in it. So Doxygen likes to generate the top level thing at the bottom. So we'll start from the bottom and we'll move upwards. So first of all, we have a GUI class or a game class. So this is a object that holds all of like everything about the game window. So every single part of the game window is held directly and is held somewhere in this class, maybe directly, maybe indirectly. So it holds a GUI controller that, oops, it holds a GUI controller that handles click events, can reset, can render, and that itself will hold some other stuff, but we'll get to that in just a second. We also see by these diamonds here that these are dependency relationships. So we'll go move ahead on this right branch in just a moment. But I'd also like to point out that the pluses here signify public members. So I'm saying this constructor up here was deleted publicly. Then we also have a private member. So this is a private constructor here, which points to this being a singleton. Um, we also have, let's look at this for just a second. We also have the pound sign, or I guess the hashtag if you prefer. That's going to be your inherited members. So in this case, we have a virtual void equals zero function. It looks like it's going to be an abstract function. And if we go ahead and we look at the other thing that this game uh, holds on to, it's actually a board controller. So, so the game window has two main parts, right? It has the GUI and it has the board. We'll start with the GUI because it's closer, and we'll work our way over to the board once it becomes relevant. So we also have this high-level GUI view, so that's every part of the GUI. So that's going to be just holding a bunch of button controllers and rendering some stuff. So it holds a vector of pointers to button controllers, which themselves are holding some or holding a stopwatch controller, which itself is related to a stopwatch view and stopwatch model. Remember, model, view, controller. So if we look at all of these button controllers, we see that everything can be clicked on, can be rendered, and it also has some kind of specialization for handling a click. So if we go look at the button controller, which is or button view, we see that it can be rendered and it has a sprite associated with it. If we go look at the button, I don't have a button model, I don't believe. No. So we'll move on to the stopwatch controller. We can see that the controller can reset, render, pause, or resume it. It can also uh, grab some elapsed time. If we look at the view, it all it does is render itself. If we look at the model, it can reset the timer. So that's when you have like when you click on that smiley face, your timer needs to reset to zero. It can be paused. When you click the pause button, it's going to pause. It can resume, kind of the opposite. And then it can get some amount of elapsed time, and that's important for writing out your time to the leaderboard. The next thing that we'll look at is the mine counter. So this is sort of the same deal. This is held directly by the GUI controller. So if you go look at the mine counter, it can just render. That's all it really needs to do because it's information that it needs to render itself comes directly from the board, which is held from this board controller. So if we look, it can render, click, set some states. So paused, it can be debug, it can be reset. We need to know whether the game is over or game is won to know when to write to the leaderboard, get the remaining line count, and then figure out whether it's paused, find a tile clicked, and then figure out whether it was a left or right click. So if we go look at the model, I'll start with that. The board model is like the heart and soul of the Minesweeper project, right? This is where the actual sweeping of mines occurs, so to speak. So we can we can get the flag count, get our mine count revealed. This is our state for our debug or paused parts. It's the game over, it's the game won. And here's the actual like where all the tiles are held. This is the 2D vector of tile models. So that's where your actual like neighbor relationships come from on mines, how you do your recursor reveal, all of that occurs inside this 2D vector. And then we have some setters for our debug, our flags. We have a way to reset the board for when you click that smiley face button again. We have a way to reveal a tile, move a bomb. So I said, okay, well, if I click my mouse, I'd rather not lose on the first click. This isn't required, but it is kind of a fun little feature to implement. It's not too bad, not too hard to implement. We have some helper functions we see these are now private, so they're helper functions to initialize and populate the board to show the bombs. That's going to be it's going to be part of your toggling debug. And then we have a flood reveal, that's our recursive revealing function. And our tile models don't really have much going on with them. It's just they have some texture information associated with them, and they have a vector of tile pointers to sort of figure out whether they're whether they're on the edge of the board, in the corner of the board, or somewhere in the middle, depends. That changes how many neighbors they have, right? So yeah, we go back out and we go look at the board model. We'll actually see a little bit the tile model. We'll see a little bit more information. So see that it depends on an array of 8 tile models and has some information that we kind of saw before in the um, board model. So we have, is it a bomb or a mine? Is it revealed? Does it have a flag on it? Is it in debug mode? And then our actual neighbor relationship here. And then we have some ways to set the mines and then get the number of bomb and flag neighbors. And then set whether it's flagged or debug and set up its neighbors. And a way to reset it. We also have our welcome window, which is pretty simple. It doesn't really depend on a whole lot. So it just can render and it has some information here on how to update text. We go look at our leaderboard. See here, leaderboard window. See, it has a bit more going on inside here. So we have a window that has a leaderboard model associated with it that can write out looks like a string name and then a time. We also have a multi-map of an unsigned and a standard string. So that was the key was the time that was written to the leaderboard, and the string was the name associated with it. So, and a multi-map basically says you can have multiple of the same key. And we can even go look at one of these little mini face button controllers. You can see there's not a whole lot going on here. We see an inheritance relationship going on here. Not too much to say about this. But we can see that Doxygen gives us another lovely UML diagram for it. Finally, we'll go ahead and go look at the main, or go back to the game class here. And if we scroll down in Doxygen, it actually gives us a call graph for each of the functions. So we can actually see kind of how my code works. So we can see that, first of all, we can see that flood reveal actually calls itself. It's highlighting in red. But if we look at the run, we can see that it kind of passes off the responsibility to each of the functions of the Minesweeper game to other functions in other classes. So we can see that, oh, if I click on it, then the board controller will figure out, hey, where was that click? Oh, okay, was it a right or a left click? Oh, okay. If it's a right click, then we need to figure out, like, hey, was there a flag on that tile? Do we need to increment or decrement the flag count? And so forth. And then we also can see that that rendering is handled as part of game, so it's doing all of that stuff. And then also the GUI itself will handle some clicks. And we can see that main depends on run. So, and if we go over to main, we can see it gives us a nice large graph of every single function relationship inside of the game. And finally, I made a draw.io version of this model because I found that it was a little bit hard to get on the screen all at once. So as we can see, we have all of our lovely functions here written in draw.io, all manually. It took a decent amount of time to make. But you can also see some classes I didn't really touch too much on, the graphics manager and then some of these other buttons here. But UML is a great way to sort of plan out your project at the start. You can use like very high level models to determine, hey, what's a problem area? What needs to be related to each other? So for example, at the beginning of the project, I was drawing out pictures and saying, hey, okay, I have a board. Okay, what other classes need to depend on the board that I've already written out? And then you can sort of identify problem areas and see where things need to be connected to each other. And you can see that it's also very satisfying to look at your UML after the project is due done because it's really fun to look through your code and see just how much work you put into it. And it's also fun to explain it. It's because seeing a big network like this is really satisfying because it really just shows you how complex code can be, and how other people might have a much more like straightforward implementation than mine. But there's just a lot of variance in how Minesweeper is made and engineered together, and it's really cool to see the differences based on your UML. So hopefully this was helpful for you guys. And yeah, happy minesweeping.